Enterprise blockchains need more than consensus. They need clear rules for participation, transactions, and sensitive data. In this module, we connect Besu permissioning and privacy to trust, governance, and security. You already have the core mental model, what Besu is, where it fits, and how enterprise networks are structured. Now we add the controls that make those networks manageable. Who participates, who transacts, and who can see sensitive data. In an enterprise blockchain, trust is not only cryptographic. It also depends on decisions made before the network is used. Who may join, who may transact, and who may access sensitive information. Without those controls, technical mistakes can quickly become compliance or business risks. Permissioning is the access control layer for a Besu network. Node permissioning decides which machines are allowed to join and peer with others. Account permissioning decides which Ethereum accounts may submit transactions. Together, they help a consortium operate with known participants instead of anonymous access. These rules should be treated as governed policy, versioned, reviewed, auditable, and aligned with the network's operating procedures. Node permissioning acts as the network's membership gate. A Besu node can peer with the consortium only if its identity is approved, typically through an allow list or permissioning contract. That means new organizations must be formally onboarded before their infrastructure participates. Unauthorized nodes may still attempt to connect, but they are denied before they can exchange data or observe traffic. This protects privacy, reduces attack surface, and makes network access and operational control. The choice of node permissioning model is really a governance choice. Static permissioning keeps rules local and simple, but every change requires careful manual coordination, especially as nodes join or leave. Dynamic permissioning adds network-level coordination, making onboarding and removal smoother as membership evolves. In both cases, the critical control is process. Who validates identity, who approves updates, and who audits changes after they take effect. Account permissioning adds a gate before a transaction enters the Besu network. It does not only ask whether a node is allowed to participate, it also checks whether the submitting account is approved. Trusted users, back-end services, or applications can transact, while unknown or unauthorized accounts are rejected before they affect the transaction pool. This matters when compliance requirements, business rules, or operational roles determine who may initiate blockchain actions. Start account permissioning with a simple question. Who or what does this account represent? Tie each blockchain account to a real user, service, or organization. Then define its lifecycle, how it is created, rotated, suspended, and removed. Access should follow business rules, not one-off exceptions. Finally, every permission change and transaction authority decision needs an audit trail. That gives teams control without turning account management into a fragile, hard-coded security risk. Think of permissioning as layered building security. Node permissioning is the front gate. It decides whether a server may connect to the network at all. Account permissioning is the secure office door. It decides whether a known participant may perform a transaction. Strong enterprise networks usually need both. If either layer is missing, an approved machine or an approved user can still become a weak point. Shared infrastructure does not mean shared visibility. A manufacturer, supplier, bank, regulator, and logistics provider may all use the same network, but contract prices, identities, inventory levels, or settlement terms may be relevant only to certain parties. That is why privacy requirements come first. Before designing smart contracts or data models, teams must decide who can see what, while preserving confidentiality, auditability, and enough operational simplicity to keep the network usable. In Besu, a private transaction is not broadcast as readable data to everyone. The public network can still record coordination information, but the confidential payload is handled by privacy components and shared only with authorized participants in a privacy group. Each participant's node must enforce identity and access rules. Applications also need to know which data belongs in public state and which belongs in private state. That boundary is the core design concern. Privacy needs to be designed before production contracts are written or participants are invited. Start by classifying the data. What can be public for coordination and what must remain confidential? Then define visibility rules. so each party sees only what they are entitled to see. Operational controls matter as well, including key management, monitoring, backup, and recovery. Finally, map regulatory duties early, such as audit access, retention limits, and data minimization. Privacy is architecture, not decoration. A good storage decision starts with one question: who needs to verify this data, and for how long? Put data on chain when it represents shared state, a proof, or a commitment that multiple parties must trust independently. Keep large files, personal data, and frequently changing records off-chain, where privacy, speed, and compliance are easier to manage. Then connect the two with hashes, identifiers, or references, so integrity is verifiable without exposing the content. In most enterprise systems, the blockchain should not hold the full document. The document stays in protected storage, while the chain stores a hash and a safe reference. Later, a verifier retrieves the authorized document, recomputes its hash, and compares it with the on-chain value. If they match, integrity is proven. Access control, encryption, audit logs, and lifecycle rules still belong around the off-chain repository. Enterprise Besu design comes down to controlled participation and deliberate data sharing. Node permissioning protects the network perimeter. Account permissioning governs who can act. Privacy and data placement protect sensitive business information. Next, we'll use these foundations to evaluate enterprise patterns and avoid architecture choices that create risk.